All right, hello and welcome to section 9.2.3, and we're asking, where are these imaginary roots located? So, based on the graph below, how many real roots does each polynomial have? So remember, real roots means it's actually crossing the x-axis. So here, for letter A, it's crossing two places. So we have two real roots here. For letter B, it's crossing here at three separate spots. So here we'd have three real roots. For letter C, we're not crossing the x-axis at all. So this had 0 real roots. And for letter D, it's only crossing the x-axis one time, so we'd have one real root. So it says graphs C and D are the same graphs as A and B, just vertically shifted. So if you notice, both A and C are parabolas. It's just we shifted A up to get C, and letter B we shifted up a little bit higher to get letter D. The polynomials in C and D do not have fewer roots. Polynomial C still has 2 roots, but now the roots are complex. Polynomial D still has 3 roots. 2 of them are now complex, and 1 is real. The way I kind of think of this is if I can draw a horizontal line going through any of these parts, that's kind of how I can determine how many would be complex. So here I can draw a horizontal line, and that means I would have 2 complex roots. If I drew a horizontal line here, I already have 1 real root here, so that would take care of this one. But I have 2 other roots right there. That would be my 2 complex right there. All right, so in parts A through D below, the graph f of x is shown. Based on this information, state how many linear and quadratic factors the factored form of its equation should have, and how many real or complex solutions f of x equals 0 might have. Assume the polynomial function of the lowest possible degree for each one. And that just means if it's bouncing, it's a degree 2. If it's crossing, degree 1, unless it's doing the cubic. Example, f of x at right has 3 linear factors because it's crossing straight through 3 times. Therefore, 3 real roots and no complex roots. So for letter A, it's crossing straight through right there. So that's 1 real root. However, if I drew a horizontal line here, that's telling me I should have 3 roots total, which means I would have 1 real because it's crossing and then 2 complex. And then that means I would have a degree of 3. Or sorry, we're talking about linear versus quadratic. So it would be 3 linear. If we look at letter B, I have it going through here. These would all be 1, 2, 3, 4, 4 linear roots. And there's 4 real roots out of that. No matter where else I would draw my x-axis or a horizontal line, it would still give me 4. Like even if I drew it right there, it's crossing 1, 2, and that's a double right there. So that's still 4 real roots. But again, if I did right there, then I would change it to a quadratic root. we see it crossing right here, so it's 4 linear. For C, now we have 1 linear. And then we have a bounce right here, so that gives us 1 quadratic. And so that would give us 3 real roots. 1, and then there's 2 here. So a double root, but it's 3 real roots. And then last, I have 2 real roots right here. And if I drew my axis right there, notice it's crossing 4 times. So what that's telling me is that I would have 2 imaginary roots, or 2 complex roots. It's 2 real and 2 complex. And these would all be linear. All right, and the last page then, it says make a sketch of g of x. Make a sketch of a graph p of x so that p of x equals 0 would have the indicated number and type of solutions. Then state what the lowest degree each function could have. So if we have 5 real solutions here, we have to make sure we're crossing 5 times, or we could have it balanced at all as well. But I'm going to have it cross. So 1, 2, 3, 4, 5. And that means our lowest degree would also be 5. If I did 3 real and 2 complex, then I would do something similar to what I have here, but I just need to make sure I'm not like going down as much at one point. So I'm going to go 1, up and down and up. So that is 3. I'm going to go down and then up. Because if I were to draw a horizontal line here, I would have 1, 2, 3, 4, 5 roots. 3 of them we know are real because we see them crossing, and then these 2 would be the complex, which means we'd have a lowest degree of 5. 1, 2, 3, 4, 5. If we're looking for 4 complex roots, we just have to make sure that it's kind of going up and down. And again, it might be helpful if you kind of draw the imaginary line here. Just make sure you're crossing that 4 times. 1, 2, oops, we want no real ones, so I don't want to. Let's see, I gotta start differently. All right, so I'm gonna start up top here. 1, 2, 3, 4. So something like that would give us 4 complex roots. Not crossing the x-axis at all, but it is have 4 complex. That means our lowest degree would be 4. And the last one, 4 complex and 2, sorry. So 4 complex and 2 real, or we'll do real first. That's a mistake on my part. We'll do 4 real and 2 complex. So we have to kind of think about our and behaviors here, so that if that's my imaginary axis here, I'm going to start up top because it's going to be a degree of 6. If you notice when we add these, that's what we always get our lowest degree. So we have an even degree. Let's start up here. I'll cross 1, the real axis. There's 1 real, 2, 3, 4, come down 5, 6. So it's very similar to B, it's just our end behavior is going to be up, up, because we have an even degree, 1, 2, 3, 4, 5, 6. So that's kind of where we're getting these complex roots, is that if we kind of vertically shifted in one way or the other, we'd see that it's crossing that imaginary axis there.